Hey guys, how are we doing today? We're going to continue with Unit 7. So today's stuff is just simplifying rational expressions. We used to do 7.5 and 7.6 together. We'll break them up for this. We could skip the warm-up. The only thing I want to remind you, because it's going to come in to play a little bit today, is just make sure, like when you're simplifying things with multiple terms in the numerator, you really are only going to simplify them if all three terms, in this case, because there's only three, have the same thing in common. So like this one's fine. You don't have to simplify it. This one, if you notice, they all have a 2 in common. You could even pull out -2. So you could, factor out a -2 from all of those and make it 1 plus or minus 4i over 2. Same thing here. They all have 5 in common. So x squared plus 2 over 1, or just x squared plus 2. And again, this one here, there's x's here and there's y's here, but you couldn't ever cancel them out because of this plus sign. You'd look for all three things that have the same thing in common, which they don't. So this answer is totally simplified the way it is. All right, complex fractions are essentially fractions within fractions. There's a couple ways we can do this. And you may kind of be familiar with how you may want to attack this from the beginning. I'll show you kind of the more methodical way to do it. And then from there, if you want, we can figure out a different way that'll maybe be a little bit more efficient. But like, I'm just going to focus on the numerator first, right? 2a plus 3, 2 over a plus 3 over b. So I need to find a common denominator to add those things together. So I'm going to take my 2a and multiply it by b over b. And I'm going to take my 3 over b and multiply it by a over a. And then that way, I'm going to get 2b over AB or BA plus 3A over that same AB, right? And then I'm going to do the same exact thing with the denominator, but basically I'm figuring out a way that I can have common denominators. So here I have a B and an A squared. So I'm going to take this one on the left and multiply it by A squared over A squared. And I'm going to take the one on the right and multiply it by B over B. Right? And again, this is just a way, we're multiplying everything by 1, so we're not changing the value of anything. It's just a clever one so that I can create a same denominator with the two terms, right? So off to the left, I'm going to have 5a squared over a squared b minus 6b over a squared b, right? So, I mean, I hate steps, but that was essentially what the first step was. Rewrite numerator and the denominator as a single fraction. So that we ended up getting, right, our numerator, 2b over ab and 3a over ab. And then when we combine them, right, so we had this step above, we can combine these. It's going to be 2b plus 3a just over ab, just like any other fraction would be. So that's the numerator. The denominator, we can go ahead and do that. It didn't have it done out for us, but the denominator is going to be, right, if we combine these things, we will get 5a squared minus 6b over a squared b, right? So what did I do? Basically, I took these two parts on the numerator and the two parts of the denominator, combined it into one part, right? And then from there, I can, I think step 2 is probably going to say, instead of dividing, right? Because keep in mind, what did we have so far? We had this 2b plus 3a, which is my numerator, divided by this, right? So again, just to write it out so that we can see it, the whole thing was 2b, whoops, there we go, 2b plus 3a over ab. There we go. And then this was all divided by what we got in the numerator, 5a squared minus 6b over a squared b. Right? So basically the next step is going to be, instead of dividing by this, what I'm going to do is now instead multiply it by the reciprocal. So we're not going to divide by this fraction, we're going to multiply by the reciprocal. So the reciprocal is going to be a squared b over 5a squared minus 6b, right? And then we're just looking to see what cancels. That's our last step, so to speak. So A is going to cancel with one of these A's. The B is going to cancel with one of these B's. And then nothing's going to cancel here. Again, you have a plus sign and a minus sign, so you really can't do much with it. You could look to see if things factor into both of them. like each one separately, but they don't. So we're going to have our final answer. We have an a that we can distribute here and here. So we're going to get 2ab plus 3a squared over, and then our denominator is actually just this because this part all canceled out. So over 5a squared minus 6b. And that's it, right? That's our final answer. So again, if you say, well, these all have a's in common, can I cancel? No, you can't, because this fourth term doesn't have it in common, right? If all four terms had the same number in common, then you could cancel, but you can't here. All right, so I'm going to actually look at this thing again. Let's look at just the original part, right? If I looked at just the original part, different way to do it, that might be helpful. So we got a lot of stuff here. Just try and ignore it. We have 2 over a plus 3 over b equals, or divided by this part. If I can find a common, the least common multiple out of all of these denominators, I can multiply both the top part and the bottom part by it. So like a, b, all right, well, I have a squared, so there's two a's, and a squared here. So my least common multiple is going to be a squared b. So I'm going to take this whole thing, I'm going to multiply it by a squared b over a squared, if that's going to write, b. Okay. And the same thing as multiplying by 1, so I can distribute a squared b to the numerator and a squared b to the denominator. And what it's going to be is a lot quicker problem, right? So, if I take a squared b and I multiply it by 2 over a, this a is going to cancel with this a, right? So that's just going to leave me with 2ab, and then my denominator is just going to be over a, and then my numerator, oh, I'm sorry, I knew I screwed that up. I'm just going to have 2ab, right? Because the a, one of the a's here cancel with this. So I just am left with 2ab for this part. Now if I distribute this to the other one, again, the b's are going to cancel, so I don't have a denominator, but I'm going to get 3a squared. So I'm going to have plus 3a squared, right? Then on the denominator, same thing, I'm going to distribute this to this part. The b's are going to cancel again. I'm going to get 5a squared here. And then if I distribute this to this part, the a squareds are going to cancel. So I'm just going to be left with 6b. So minus 6b, right? And that would be, again, you check to see if anything simplifies, but that is the exact same answer as the one we had down here, right? So it's a much quicker and easier way if you can find a least common multiple, multiply the numerator and denominator by that. Same thing as multiplying by 1, so it works. So whatever way you want to do is fine. So we have all these steps, we kind of did it. These partner practice problems, you can take a look at them and try them if you want, but if you can do the ones with the work, then you'd be okay. The other thing that I want to teach you guys is this second part, which is, again, it's not a complex fraction, it's just, it's just a regular fraction, but just looking to see what factors, right? So if you were trying to simplify this, I would say, okay, I'm going to look at these two parts separately and try and factor what I can first. So the numerator is going to factor into x minus 5 and x plus 3, right? And my denominator is going to factor into conjugates, x plus 3, x minus 3. And x minus 3. Now what do I notice is that, great, this and this cancel, right? Seems like a pretty simple problem. Final answer is x minus 5 over x minus 3, right? Obviously you can't cancel out the x's, they're stuck there. But this is not the final answer. This is not the same thing as the original thing, right? And you might say, well, why? Well, if you look at this original thing, right, you always remember about denominators. You can't plug in anything that would create 0 in the denominator. So if you said, okay, I know that plus and minus 3, I can't even plug in because it would create 0 in the denominator. Now, if you just looked at your final answer, you would just say, well, the only number that I cannot plug in is positive 3, because if I plug in positive 3, I get 0 in the denominator. So, okay. But if you looked at this and you said, I can plug in negative 3, you'd be right? Because negative 3 minus 3 and negative 3 minus 5, you're just going to get some number there. But you can't, right? If that means this is different than this. You can't have This one have not be able to plug in negative 3, and this one you can plug in negative 3, then they're not the same. So it basically, when you cross these out, you kind of lost the idea that you can't plug in negative 3, because obviously if you looked at it this way, you couldn't plug in negative 3 because you get 0 here. So before you finish this answer off, we usually put a comma and we say, oh, by the way, x cannot equal negative 3, right? And then that is your final answer. You don't have to state that x cannot equal positive 3. It's understood that you can't plug in positive 3. You don't have to ever say that, because if you plug in positive 3, you can see you get 0. You couldn't tell by looking at this that you can't plug in negative 3. So you have to state the one that's not obvious, right? Essentially the one that you crossed out. Now, if I say x minus 5 over x minus 3, x cannot equal negative 3, it is mathematically the exact same thing as this, and it's more simplified. All right, so that's it for today.